start the lecture, any of you have any questions? Okay, so I have kind of semi-TED talk for you at the beginning of the class because I just felt like someone should tell you these things, and I feel like maybe I should be that person. So any of you know what is minimum wage in Idaho? All of you know that, right? I mean, most of you. So I had minimum wage job myself too. I was getting paid $8.25 for each hour. So how much do you think is a scientist role job hourly paid? A guess? 20? Any other number? Any guess? 35. Any other guess? And I'm just throwing out these numbers based on my personal experience and my friends that now they have jobs. $60. If you're a scientist, you get paid $60 an hour. It means that if you have a minimum wage job, and some of you are working right now, and you think that you're earning lots of money. So I have news for you. If you study well in college and get your degree and have a good job, you can just get that much of money that you would be earning in one day working so hard just with 1 hour of working. And as I said, these numbers that I wrote here is based on my personal experience. I have my PhD in chemical engineering, and all my friends, and me included previously when I was in the industry, we were getting paid $100K per year. And if you have a minimum wage job, you can still pay bills, but it would be $20K per year. As I said, depending on the industry, where you're working, whether you're working at Walmart or like a daycare or a movie theater, depending on those, these numbers are different. But the point is that, having a college degree helps you in life. And as an educator, I feel like it's my responsibility to tell you these things. So if you have friends that distract you from studying or like encourage you to not go to the class, don't care, and all those things, I feel like those are kind of your enemies, And I know that some of you may think that she's so strict, you have so many homeworks, all that. But I have news for you. This is a really cruel world that we're living in. Harder your job is, less you get paid. And I experienced that myself, I was working in a daycare. I was changing diapers and like wiping, cleaning the ground and then all that, when I was searching for a job. And I was like feeling so tired every day. I had backache, neck ache, all sorts of pain for just like $9 an hour. And then my salary per month was like, at best case scenario, $1,400 per month. But then I got a scientist job, and then my salary was like $45 an hour. And I wasn't even working that much. I was just in front of my computer doing literature review, writing a report. Much easier job. So what I'm telling you is that if I'm trying to give you some direction and guide you to what to do, how to study, I want you all to succeed in college. If you have a degree, any bachelor's degree, roughly, you can earn at least $50K per year by doing much less. And I want all of you to succeed, And I don't care if, some of you think that I'm strict, or you think that, I'm not as easygoing as your other professors. They maybe don't want to prepare you for real world, I want all of you to succeed in my class and all of your classes. And this is the way, that can happen. For you to study and listen to me, come to the class, do the homeworks, and if you decide to pass this class, as I always told you, and I have some of your classmates that I have tutoring sessions with them one-on-one anytime that they're available. Some of them are available during the weekend. Some of them, they are available after all their classes. Some of them early in the morning, 8 a.m. I work with you. I make sure that you succeed. I just want you to know that. And all the rules that I have in the class, everything is that I want you all to get your degree, okay, and succeed. And I know most of you, if not all, chemistry is not your major, you're forced to have this class and all that. But I want you to learn, not only my class, how to study and succeed and get your degrees. And hopefully, even if I can inspire 2 of you, that's good news for me, okay? So this is just like giving you an idea. And as I said, these are based on my personal experience. Don't say that, she said I'm going to earn like 60K, I didn't, now it's like 50, It's just kind of like approximation of these numbers, okay? The other thing that I wanted to clarify, I had some students that they were telling me that half of the class failed last semester, half of the class failed this semester. First of all, this semester is not over yet, right? And what I was quoting previously was exam 2 grades that half of the class were failing. Last semester, out of 250 students, 39 students failed. And those students were the ones that literally didn't show up to the class, didn't hand in any extra credit assignments, and after I almost added 3 letter grades to everyone else that they were doing extra credit and all that, they still failed. So those 39 people, I couldn't help because they didn't put any effort whatsoever. And I think 15.6%, right, 16 or like 15 students out of 100 is not that bad, right? And for our class as of right now, just before coming to the class, and that excludes the makeup exam or tutoring session, but I still should grade your makeup exams, and I add tutoring sessions or like SI pass at the end of the semester. But 13 out of 120 are failing, which is like almost 11 out of 100, which I think is not still that bad. But my aim is that for all of you to pass, and for those of you who have like D's or C's, to get an A. And if you listen to me, I make sure that happens, And I want to convey that to you, that I deeply care about you, as I said. And I want to, help you all to learn and also learn how to study, because I know some of you don't used to studying, but you should study to succeed, right? And again, remember, just like, if you study 4 years, then you can earn lots of money for the rest of your life. So kind of just giving you perspective. And I just wanted to clarify that too, because as I said, some students had an impression that last semester half of the class failed, this semester half are failing. So that is not accurate. And if you listen to me, I make sure that I assign as many extra credit opportunities as possible. And if I see a little caring from you, I make sure that all of you do well, okay? Okay, this is another thing I wanted to say. And the other thing, just a reminder, you don't have any lab this week. And the reason is that I want to kind of finish or like at least be halfway through chapter 10. So when you go to the lab, you know what's going on. So just a reminder, you don't have any lab this week. And I'm going to send an announcement on CHEM101 lab as well. But since most of you have the lab, I just wanted to briefly remind you that. Okay. Any question about anything that I just said so far? Are we good? So just keep doing what you're doing. Just finish your homeworks. And you have homework 13 due this Wednesday. After that, you have one more homework, one more quiz, one in-person exam before your final exam. And I try my best to have as many extra credit opportunities as possible. And as I said, I will add 5 points out of 1,000 to each SI pass session, tutoring sessions that you go. So by attending more and more, you can increase your grade as well. So even now, if you're failing, just by doing those things, coming to the class, paying attention, and then doing well on the extra credit homeworks, in a sense, that I give you during the class, I don't see how you cannot pass. As I said, in my class, someone should be really persistent, that I don't want to go to the class, I don't want to put any effort. They should persist on failing. Otherwise, all of you are going to pass, okay? Good? Okay, if no question about these, things, I'm going to talk about Pauli exclusion principle. So it's kind of like different from what I was talking about earlier. But do you guys remember what was Pauli exclusion principle? I talked about the rules. I didn't explicitly say the name in the previous session. But do you remember when I told you when we have electrons and we want to fill them in orbitals, right? For instance, if I have one s orbital and we can use something called orbital diagram, which means that we have a box or like a square, right? And then we put electrons in there. And if this is like 1s, can I put 3 electrons here? No. We can have maximum 2 electrons. Can I have, and then we show electrons with half arrows, whether like this or that. And I told you this is a spin up, this is a spin down. And I told you spin is a fundamental property of an electron, and this is all we're going to learn in this class. As long as we know that we have 2 arrows, one of them up, one of them down. Okay? And you can also write complete arrows. That doesn't matter. But as we write these electrons, sometimes it becomes more difficult to fit them in the squares. For instance, if I have like P subshell, imagine this is 3P, right? So if I put them completely and then I want to, fill that, it's kind of like becomes harder to see. So in order to be concise, we write half arrows. But necessarily, if you put complete arrows, that is correct too. Okay. So based on, I have like another color. Okay. Based on Pauli exclusion principle, in each of these squares, which shows us the orbital, we can have maximum 2 electrons. Okay. And the spin should be opposite. Meaning that, and this is one question that I asked you at the end of the class. I told you which of the following contradicts, and I'm going to write the question here as well. I told you which of the following contradicts Pauli exclusion principle. Pauli exclusion principle. And then I have like, for instance, 2p orbitals. And remember, 2p subshell, each subshell has 3. When we are on 2p, each subshell has 3 orbitals. And each of the orbitals we denote with a square, right? So if I ask you how many orbitals one s subshell has, what is the answer? We only have 1. Okay, you can also remember the configuration that when you had s, we said s orbitals are spherical, right? And there was only one possibility because this configuration was symmetrical, right? But when we were working with p orbitals, we had 3 different configurations, px, py, pz, remember? So in 2p subshell, we have 3 orbitals. Okay? So if I put 2 electrons they have the same spin, is this consistent with Pauli exclusion principle? No, right? Remember, you should always have opposite spin. So, for instance, this is consistent, that is fine. Or if I have like this electron configuration, that is also consistent with Pauli exclusion principle. But if I put 3 electrons in one orbital, that is not consistent. We have maximum 2 electrons with opposite spins. Any questions about this? And if you have questions at any point, as I said, just feel free to ask me, because sometimes your friends have questions too, but they don't want to ask. And before you asking me questions, I don't know if you have a question, okay? Good? And as I wrote here, we symbolize these electrons as two arrows pointing in opposite directions. For instance, if we want to fill out one s orbital, we put two electrons with opposite directions, opposing directions. Good? So that was Pauli exclusion principle. Another rule that is really important and helps us to write electron configuration, which is Hund's rule. Hund's rule tells us that when we want to fill orbitals with electrons, and orbitals that they have the same amount of energy, we fill them singly first, then fill them out. Meaning that if I want to write orbital diagram of carbon, for instance, and as I said, we have one S, we have like these squares or these boxes, whatever you want to call them. And then 2p, remember, we have like 3 different directions for p orbitals, right? Can anyone tell me what was the shape of p orbitals? Dumbbell-like, exactly. So one of them could be, if this is like x, this is y, this is z, one of them would be like this, right? And then we call that px. The other one was like that, we call that pz. The other one was like this, we call that py. That's why we had 3 different orbitals, right? So if I want to fill them out, first, so 1s has just like one orbital and the energy is just like certain amount, right? So I fill that singly first, then I pair that up. And then the same thing for 2s. So the tricky part is for p. So if I want to fill out p orbitals, first I put electrons in px, then py, then pz. After I put that, then I pair them up, okay? And depending on how many electrons we have, that I'm going to solve so many examples for you, so hopefully you can learn this. So if I give you a question and I ask you this in the quiz that I wrote for you at the end of the class that I'm going to give to you. So which of the following contradicts Hund's rule? And if I give something like this to you, so I guess if I put the other, so that contradicted Pauli exclusion principle too. But if I have like 2p, for instance, here, and I have 3s here, right? And then this one is filled too, I'm not allowed to fill these like that. First, I fill p orbitals singly, right? And then I pair them up. Does that make sense? Any questions? So if I want to write, let me do an example so this becomes clearer. So if I want to write electron configuration for aluminum, for instance, the first thing, so we want to write electron configuration for aluminum. And electron configuration is nothing but showing how electrons are being distributed in different orbitals. Okay? Do you remember in Bohr model we said that we have different shells or different orbits? In first shell we have maximum 2 electrons, in second shell we have maximum 8 electrons, remember? So now in quantum mechanical model we said we don't have orbits anymore, we don't have only shells, we have also subshells, we have orbitals. And then we have 1s, 2s, 2p, all those good things, remember? So if I want to know how electrons are distributed between these orbitals, right? So the first thing that you do, you look at the periodic table and see the atomic number of element that I asked you. And aluminum is 13. So can you tell me how should I start writing this? Do you remember?
2 electrons go on the first.
So the first one is 1s, right? So we have 2 electrons going there. What is next?
Then there'd be 2s.
Excellent. Yes, we have 2 electrons going there. What is the next one? Exactly. How many electrons here? So we have 3 orbitals, that is right. But each orbital can have 2 electrons. So what would be the... Exactly. So right now after you write some of them, you start counting. 2 electrons plus 2 electrons would be 4 plus 6. So right now we wrote 10 electrons. How many are left? 3. So what is the next one? So I still should continue writing this, right? What is the next one?
3s.
Exactly. How many here? Exactly. So remember, it doesn't matter which shell you are or what is your n. S orbitals, they have maximum 2 electrons because they have 1 orbital. What is after 3s? Do you also remember that? Exactly. So now we have 12 electrons till here, right? How many are left? Exactly. So this would be your electron configuration for aluminum. And how you can remember how to write it as your friend did, this number is your n number. This is basically your orbit or shell, right? Hopefully you can see that color. It's not too much annoying to the eye. Okay, this is your shell. And do you remember when n was equal to 1, we only had 1 subshell. And that was S, right? So that's why you only have 1 S. You don't have 1 P. Because n equal 1, you have 1 subshell. What about n equal 2? Do you remember when n was equal to, how many subshells you had? So whatever the number is here, the same amount you have subshells. So if n equals 2, you have 2 subshells. Do you remember what were those? S and P, right? So when n equals 2, you have 2 subshells, S and P. That's why you write 2S, 2P. That's it. That's why we don't write 2D, for instance. Because n equals 2, you have 2 subshells. And then the same thing with 3. If n equals 3, you have 3 subshells. And then SPD. But you also look at the number of electrons. So you have here maximum 13 electrons, so you don't have to fill the whole P orbital. And also, we don't have to write 3D or like 4S, because this is the maximum number of electrons we have. Does that make sense? Questions? Good. So in the next slide, whatever we talked about, I kind of wrote here so you have like more organized reference to study. And also in the last lecture, when I posted the slides, I included pictures of your book. So you have your book to study too. Sometimes students are more comfortable to study the book. That's why I encourage the students to have the book. So you have those too. I encourage you to look at them and study them. So if you remember from the last class, we said, do you remember how electrons fill the orbitals? Do they fill orbitals with higher energy first or lower energy first? Lower energy, right? That's why when you have like hydrogen atom and it has 1 electron, you put that electron in n equal 1 or like 1s orbital. You don't put it on 10s, for instance. We start filling orbitals which have lowest energy possible. That's why first we fill 1s orbital. And then we fill 2s orbital. And then 2p. And as I said, remember n equal 2. And these numbers here, I kind of like highlighted these for you. These are your n number. These are your shell or principal quantum number, remember? So when n equals 1, you have only s subshell. When n equals 2, you have 2s, 2p. And then when n equals 3, you have 3s, 3p, but here this is an exception that 3d has higher energy than 4s. So this one you should kind of remember. And as you solve examples, it becomes clearer, I hope. So you just write 1s, 2s, 2p, and you can just memorize this order here. If you memorize this order, this order, most likely you can answer the question that they give you in exam, okay? So 1s, 2s, 2p, 3s, 3p, and here you feel 4s first, then 3d, and then 4p, okay? And remember, your s orbitals in general, they are like this. They can have maximum 2 electrons. And that is the same for 1s, 2s, 1s, 2s, 3s, 4s, 5s, and so on, okay? And if you have p orbitals, or like p subshell, you have 3 p orbitals, okay? And each of them can have maximum 2 electrons. And when we want to fill them out, you fill them singly first and then pair them up. So that is the case for 2p, and remember, we don't have 1p, right? So 2p, 3p, 4p, 5p, and so on. Good? And if we have D subshell, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is D subshell. What is the, and then that is the case, and we have D subshell when n equals 3 above, right? 3, 4, I guess I write 3D, 4D, 5D, and so on. So what is the maximum number of electrons in S subshell? 2, right? You say 1, 2. So this is the maximum number of electrons, 2. What is the maximum number of electrons in P subshell? Exactly, maximum number of electrons. What about D subshell? 10, exactly. Number electrons, 10. And as I emphasized here, we have maximum 2 electrons, maximum 2 electrons, maximum 6, maximum 2, 6, 2. And then for D, we have maximum 10 electrons and 6 for P. And we write these electrons as superscripts here, like 2, 2, 6, 2, 6, 2, 10, 6. Any questions so far? Are we good? No questions? Okay. If no questions, I'm going to just do this. And I ask you, write the electron configuration for nitrogen. So what is the first thing you do? Exactly, as some of you already did. You look at the periodic table, see what is the atomic number of nitrogen. It's 7, right? Remember the number that is listed above. Atomic number is number of protons. It shouldn't have decimal point, unlike atomic mass, right? So that is your number of protons, which we learned is equal to number of electrons because your atom is neutral, right? So if I want to fill out the orbitals, which one do I fill first? 1s, right? How many, so this is shell number this tells me the shape of orbital, remember, shape of orbital. So how many electrons s orbitals can have maximum? 2, exactly. And this would be number of electrons. So we filled one s with 2 electrons, but we still have 5 more left, right? Because the atomic number of nitrogen is 7, we have 7 electrons total. So what is the next one that I should write? Exactly. How many electrons maximum s subshell can have?
2.
Exactly. So now again we count. I put 2 here, 2 here, right? 2 plus 2 would be 4. Is it 7 yet? No. So what is after 2s? 2p. How many should I put here? So I have 2 here, 2 here. What is the maximum number of electrons that can be theoretically in p orbitals or like p subshell? 6, right? So I can have, and if you remember, and I'm going to write the, okay, that was like really long, bothers me. Okay, let me do this. Okay, better. So 1, 2, 3, 4, 5, 6. This is the maximum. But we should look at our elements, see how many electrons are actually there, right? So I put 2 here and then 2 here. So how many are left? Exactly, 7 minus 2 plus 2 would be 3. And I put 3 here, okay? And if I want to write the orbital diagram for this element. So this is 1s, right? We put 2 electrons with opposing spin. And then for 2s, I put 2 electrons with opposing spins, right? And then for p, I know I have 3 orbitals in 2p subshell, right? So remember that when we want to fill these out, we fill them singly first. So 1, 2, 3. And that is the 3 electrons that we wanted to fill, right? Does that make sense? So that 6 that I talked to you about is the maximum number of electrons that can be in 2p subshell. But depending on which element we are working with, this can be not filled, right? It can be, partially filled. And something that I would want you guys to attention is that what is the maximum number of n that you see here? Do you remember these guys are your n number, which is shell number? So you see up to n equal 2, right? You don't see 3s or 3p, right? And what period in the periodic table nitrogen is? Period or row number 2. And if we consider the outermost shell, right? Remember, based on the Bohr model, and I told you Bohr model is really important and we should learn it because we're going to use it in quantum mechanical model too. So outermost shell means the highest number of n that you see, right? So if you consider nitrogen, it has n equal 1, n equal 2, and that's it, right? You have electrons until n equal 2, and that is your outermost shell. How many electrons exist in n equal 2, which is your outermost shell? 5. Exactly, 2 plus 3 equals 5. So I'm going to write 5 electrons exist in your outermost shell, or I guess I should say in nitrogen, not you specifically. In nitrogen outermost shell. And what group nitrogen is in the periodic table? 5a, exactly. Do you see a trend? So the largest number of n that you see when you write the electron configuration, that is your period or row, that specific element is located in the periodic table. And the number of electrons that exist in that specific shell is your group number. And that applies to your main group elements. And when we're using the naming system that has A in it, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Okay? So with that, I'm going to write a definition for you, which is valence electrons. So valence electrons are electrons that are located in the outermost shell. Meaning that after you write the electron configuration, you look at the highest number of n that you have. You count the number of electrons, and that would be the number of your valence electrons. Okay? And the number of valence electrons matches the group number that the main group elements are located at. So if I ask you what is the number of valence electrons in fluorine, what group fluorine is in? Exactly. So what would be number of valence electrons? Exactly. What about carbon? Group 4A, right? So you have 4 valence electrons. Any questions about that? Are you all comfortable? Let's do another example too. So if I ask you, write the electron configuration for phosphorus. So you look at the periodic table, what is the atomic number of phosphorus? 15, right? So, and this is, you can also remember this, the order that orbitals are being filled, write it, and then depending on what element I give you, start counting electrons. So you can write 1s2, 2s2, 2p6, 3s2, 3p6. And remember here, you have 4s2, and then 3d10, okay? And this element that I gave you has 15 electrons. So what you do, you say, okay, 2 and 2 is 4, plus 6 is 10, plus 2 is 12. So till here I have 12. Okay, how many more electrons do I want? 3. So you can cross this out, write 3, and then just eliminate the rest. So your electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p3. And you can check your answer. I told you this is your period number or row number, right? Period number. So look at phosphorus. What group, what row or period in periodic table it is?
3.
So the row is 3, right? So that is consistent with what we learned. So what is its group number? Group number? Can everyone see phosphorus? 5A, right? So based on what I wrote here, the number of valence electrons are 2 plus 3 because we count the number of electrons here, right? So that is correct too. So you know that you wrote the electron configuration correctly. Does that make sense? Okay, before I give you the quiz, any questions? Okay, can you guys come help me with this? Okay, distributed this part of the task. Okay, distributed that part of the task. So I have 5 questions for you guys, and hopefully. You can just start answering. Doesn't take long. Everyone has one? Okay. And for people who are watching at home, just reach out to me so I give you the extra credit assignment. Because if anyone, when they're missing the lecture, I expect them to watch the recorded lecture. And I also made an announcement about it on Canvas. So I think everyone now is aware of extra credit opportunities in the class. You just give me the Scantron. The questions, just keep them for your final or like for your next exam. Thank you. Thank you. Just give me the Scantron. Yeah, just the Scantron. Thank you. Thank you.
Too much stuff in my hands.
Okay. Thanks. Just make sure you have your names. So,
For like writing electronic configurations,
Thank you.
I don't remember the name.
oh, you did that? Okay, thank you.